Hi everyone, in this video we observe how to construct multilinear alternating map by having only information on the basis over exercise 2. And in this exercise we have vector space R to the 3 and we have the standard basis E1, E2 and E3. And additionally, in this exercise, we consider this set, which gives us the info, which is determined by the order we put in the first explanation. So now we observe that actually this set can be defined E1, E2, because E1 is less than E2. And it contains E1, E3 and E2, E3. For instance, E3, E2 is not here because E3 is not less than, strictly less than E2. And okay, and the other information is that T is alternating. So alternating means that first, whenever we have two equal entries in two different positions, we get 0. And changing the order of the coordinates is determined by the powers of the -1, and this power is determined by the number of the changes with respect to symmetric group S2. So in this case, we only have one changes, and by the S2, we just consider the position changes. And first we want to define the images of the bases under T by giving this information. So since T is alternating, by this information, we know that TEI is equal to 0. And similarly, we determine these images. And these orders are given by this set. So we can directly take these images as the values under F, which are given in the question. And finally, we also need to observe that when we change the basis, when we change the order, we get minus values. And that's all. Okay, so now we know the images of the tuples when the tuples contains the basis elements. And finally, we want to extend this map multilinearly, because T is multilinear. So for this, first we consider the expansions of these vectors with respect to the basis, standard basis. And by the definition of the multilinear map, we are going to extend this transformation. So we distribute the addition to the other one, and we take the scalars out of the transformation. So that means AX will be outside of the T, and it remains T of E1, E1. And similarly, we compute the A1, AY, T E1, E2 plus AZ T of E1, E3, BY T E2, BX T E2 E1 plus BY T E2 E2 and BZ T E2 E3, and finally we have C times X T E1 T of E3 E1 T E3 E2 and C times Z T E3 E3. And from here we know that these are going to be 0, and we only plug in the values of these maps when we compute previously. So that means finally we get the equation 5 times AY minus 2AZ plus 2BX plus BZ 2 times CX minus CY. So we can determine the images of these two vectors as like this. So this T is this multilinear alternating map is determined by this equation. And yeah, this is all what I want to say. If you have any questions, please don't hesitate to tell us. Bye-bye.